scholarship and placement company. We promise you an excellent info session today that will be led by one of our instructors, Michael Cullen. And Michael will link a notebook in the chat that he'll be using during his demonstration. Please make sure you have access and can follow along. And if you need it resent, we're happy to do so throughout the presentation. But to start things off, I want to give you a quick overview of our program and everything that we offer here at the Data Incubator, and then I'll hand off to Michael, who will jump in for our live demonstration, and then we'll leave some time at the end for questions. If you do have questions throughout the presentation, please put them in the Q&A section and we will answer them at the end of the presentation. As a reminder, our session is an hour long today, so if we don't get to all of your questions, please email us at admissions@thedataincubator.com and we'll be happy to help you. We'll also drop that email address in the chat box a few times throughout the presentation. All right, so to get things started, a little bit about the Data Incubator and what we offer. Well, the Data Incubator focuses on training people to become data scientists and analysts. And why is this important? Well, it's really because data scientists and data analysts have the ability to work with the latest tools on unstructured and structured data to drive business value. It's a big need in the world right now. We work with companies in a ton of different industries, ranging from tech to retail, healthcare, and many more. Every company has data and wants to use that data to drive value for them. We know there are a lot of other data-focused programs out there, so I'm sure you're wondering what we do at the Data Incubator that's just a bit different. Well, what we've found when you're looking at training, there are really two different types. One being fast-paced and efficient, and two being slower and focusing on understanding and completion rates. University is one example where you receive a more detailed understanding, but with a lot more time invested. And then on-the-job training is usually very quick and efficient, but maybe you're not fully understanding what you're doing. So we've taken all of these aspects and combined them together to find a great middle ground for training. Our program is fast-paced. You'll walk out of the program knowing a lot about data science and data analytics and the real-world business applications, and with a deeper understanding as you would get from university. Also, all of our instructors are PhD and master's holders and have completed these programs themselves and know how to provide that in-depth training that you are looking for. We are so excited to announce that for our fall 2021 cohort, we will now be offering 4 data-focused programs. We'll be offering our successful full-time data science fellowship program and a more flexible version of that with our part-time data science program. We are also offering our part-time data analyst program and our new full-time data analyst program. So a little bit about each of our programs. All of our programs are intense. They are built around hands-on data-focused curriculums. We offer both full-time and part-time programs, and both are packed with a lot of information and tools. All of our programs are thorough. Each week we'll focus on a different data science or data analytics tool or approach. And in addition to our lectures, we have our students participate in hands-on practice. We really believe in fostering an interactive learning environment. So in each program, students will work on a mini project to focus on the data tools you are studying that week. Additionally, all of our programs are very collaborative. We want students not only to work with their colleagues and instructors, but also have the opportunity to network and connect with our hiring partners. Each program is career focused. We have career coaches that help you succeed in your data focused careers. You'll not only learn how to present your best self by attending our career search workshops, but you'll also have the opportunity to work with one of the #1 resume writing companies to get you a polished resume and cover letter. And lastly, all of our programs are interactive. Every student in our program are provided a Jupyter server for the duration of their course, so students can follow along in lecture and see and edit raw code that's being run. And students will also receive immediate feedback via our interactive grader. So a little bit about our full-time data science program. It lasts for 8 weeks with classes held daily. You can expect to spend about 40 hours per week in class working on assignments. Here's an overview of our full-time curriculum broken down by week. Please email us again, admissions@thedataincubator.com, if you'd like to see a more detailed overview of the curriculum. And then for our part-time program, again, same curriculum as our full-time program, but this program lasts for 20 weeks with classes held Monday and Wednesday from 7 p.m. to 9:30 p.m. Eastern. You can expect to spend about 10 hours per week working on your assignments outside of class, and office hours will be available each week. You'll receive the same excellent curriculum and training as our full-time program, but at a slower pace. And all of the sessions are live and instructor-led, so you're still able to interact with your instructors and peers and ask questions. So our data analytics program overview for our part-time and full-time program. The part-time program lasts for 20 weeks with classes held on Tuesdays and Thursdays from 7 p.m. to 9:30 p.m. Eastern. You can expect to spend 10 hours per week working on assignments outside of your lectures, and also office hours will be available. The part-time program is a great option for those that are working or still wrapping up their degree, as it will allow you to work full-time while advancing your data-focused career. You'll receive the same excellent curriculum and training, but at a slower pace. And again, the sessions are live and instructor-led, so you will be able to interact and ask questions. For our new full-time data analyst program, again, same curriculum. It lasts for 8 weeks with classes and office hours held daily, and you can also expect to spend 40 hours per week working outside of class. The application process for the program is composed of basic information, resume review, and a career goal focused group interview. And there's also an optional scholarship application, which we will touch on a little bit more later. And throughout the course, you will work on many projects to demonstrate an understanding of core data analytics topics covered by our expert instructors. As mentioned, not only will you be set up with a virtual environment, but our curriculum will have you learning with open source tools and popular programs like Python, Pandas, JupyterHub, and Tableau. Here is an overview of our part-time data analytics program curriculum. This is broken down by modules. If you'd like a more detailed review of this curriculum, or if you have some questions, again, email us at admissions@thedataincubator.com. So a little bit more about scholarships and the types of students that we admit into our programs. For our data science programs, we admit 2 types of students. Fellows are offered the tuition-free scholarships for our full-time program, and we offer a limited number of these scholarships to highly qualified candidates. Fellows are expected to leave any current employment to attend our programs and are expected to interview exclusively with our hiring partners. Scholars are tuition-paying students that participate in our program. They are not required to interview solely with our hiring partner network, and they maintain any current employment. Scholars still have the same access to curriculum, resources, and tools as our fellow students. And just keep in mind that the full tuition scholarships for our data science program are not offered for our part-time program. And for our data analytics program, we are also excited to announce our Data Analyst Diversity Scholarship Program, which aims to help remove barriers and provide opportunities for women, veterans, LGBTQ+, and students from racial and ethnic backgrounds that are traditionally underrepresented in technical roles. This scholarship is only available for our full-time data analytics program. It is not offered for our part-time program. So with that, that is just a little bit about our program. I want to make sure I leave enough time to pass off to Michael to lead you through our live data demo, and then I will come back at the end to answer some questions. Again, please put those questions in the Q&A section, and I will stop sharing my screen, Michael, so I can pass over to you.
All right, thanks so much, Sierra. And I'm going to put these links in the chat again. One of these will take you to a GitHub repository with the material we're working with today. The other one will actually just launch that material kind of in an interactive server environment that you can sort of play around with. And let me get my screen share going. That'll be this one. So as I said, that first link that I posted is to a GitHub repo. This repo contains material for both this info session demo and a sort of part 2 that I do. So we'll be in this demo 1. So if you want to, keep this code or work on it more after today, this would be a good place to, clone the repository or download it, or, star or follow it or something like that. The second link I posted is going to take this repository, and I'm going to show you what happens if you click on it. It's going to spin up a Jupyter Notebook server that has all of the material in the GitHub repo. So you should see something like this happen. And in there, we'll be working in, of course, demo 1, Pandas Excel. So under this little file browser, you'd click in there, and then we're going to be looking at this notebook here, generate report .ipynb. So if any of you are not super familiar with Jupyter Notebook, as a platform or piece of software. You are looking at a Jupyter Notebook server right now. That's kind of what this current interface is. We're in just sort of the file tree browser part of it. Probably looks pretty intuitive because we browse files a lot. But let's click into generate report here. And this is the content we will be working through today. Go ahead and clear my output. And again, if you are not familiar with Jupyter Notebooks, you are looking at one right now. We use this format, as Sierra mentioned, a lot in the fellowship for our sort of textbook curriculum materials for the mini projects that you work on each week or throughout each module. And they are generally kind of a ubiquitous tool in data science, whether you're working in Python, R, Julia, all kinds of languages. We're working in Python today, which you can see from up here. It says Python 3. And again, for those of you, if you're not super familiar with these, I just want to give a quick rundown of what we're looking at. So Jupyter Notebook is a sort of, it gives us this format or this interface in which we can have blocks of code that we can run. That code can be in various languages, depending on how we set things up. And also we can have text, markdown text that gets formatted in kind of nice little HTML like this. And so it gives us a really nice way to work interactively, running chunks of code, annotating or including other things with text, images, links, and so forth. And it's kind of modular. So I can run this piece of code. I can create a new cell, run other code, run one cell over and over again. And the background environment sort of persists from cell to cell. So anything I do here, I can reference in another cell, where it still sort of lives throughout my session, right? So that's the Jupyter Notebook. All of these cells, these little blocks where you see this in, and then you'll see brackets next to it. These are code cells, so we need to run these as we're going through the notebook if you're following along. You can run a cell a couple different ways. I tend to use shortcut keys. Shortcut key for that would be holding Shift and pressing Enter. So I just did that, and you can see that this went from a 1 to a 2. You can, I suppose, click this Run button up here. I think the shortcut key is much easier. You can find all kinds of different ways to run a cell, but I will just be doing Shift Enter. Okay, so that's the basic rundown. I might note a few other things about Jupyter Notebooks as we go along, but I just wanted to make sure everyone was, I guess, pun intended, on the same page before we got into like the topic for today. And the topic we'll be looking at is sort of automating a reporting process, working with Excel files in Python. So this is going to be kind of a fundamental skill in our data analyst program. It's also something that comes up a lot in the data science like fellowship program, which is to say working with tabular data that comes in tables or sheets of tables or spreadsheets, and in particular working with Excel files. And what we want to do today is we want to take some input Excel file, and we want to be able to compute certain metrics on that Excel file and create a report. And we want some flexibility, maybe to group things different ways depending on how we want to split up or aggregate. And we want some reproducibility so that if I get my program working with one file, then maybe I have another file from the quarter before, or maybe a couple months from now, I can use this program again and put in a whole different Excel file. On a technical level, that's kind of what we're looking at. But let's talk about the sort of business problem. And so here we're living in the world of influencer marketing and kind of like ad buying. So I'm actually going to pull up the Excel files. I'm going to switch my screen share really quickly here. But we are dealing with a file that has a couple of sheets. So you're looking at it right now, I guess 2 sheets. One of them is called posts. Maybe I'll start there. And posts has, by date and an influencer, someone, we are paying to make social media posts. That influencer's name, the number of followers that they have. Here we've sort of created bins or groups out of how many followers they have, the cost of a particular post, the number of likes it got, the comments, the shares, and the clicks. Clicks here meaning, we include like some sort of link to, let's say, our website. And the intent is that, they see the ad or sponsored post, they click through, and hopefully they buy something, right? And so what happens when they click through? What happens when they hopefully buy something? Well, that's something that we are tracking in this other sheet called conversions here, which is formatted a little bit differently. This is sort of in like a wide format where we have dates going across the top. We have influencers going down the, rows here. And here, if we see something like this 1 in this box, that would say that on that day, January 8th, we had 1 conversion that we could attribute to that influencer, Albert Taylor. So that means that on January 8th, let's say somebody clicked on a link from one of Albert Taylor's posts and bought something. So that's what we're saying with conversions versus clicks. Okay, very zoomed out there. So that's the data that we're working with that sort of image in mind. Let's get back to our notebook. So again, we have these columns and posts, and then conversions is sort of pivoted into this wide format, I guess, where the columns are each date. And what we want to do, let's say we are data analysts. We've been asked by our manager to get some new metrics based on our previous marketing campaigns. Because what we're doing right now is, we're tracking things like, oh, here's how many people liked this post, from this person, and we spent $80 on it and so forth. But we want to maybe get to more immediately valuable metrics. And so we've been asked to compute 2 things, or we want the ability to compute 2 things. One of these is cost per acquisition. So how many dollars do I spend to get someone to buy something? How do I compute that? Well, let's say for some influencer, let's call him Michael Cullen, we spend $500 on sponsored posts. And from all those posts and all their views and likes and comments and clicks, 4 people end up clicking through the link in the post and finally making a purchase. So as a result, we spent $125 on each conversion, right? Now, maybe 50 people clicked through to our website, so that would mean we spent $10 per click, but we were spending $125 per conversion. So that's one thing we'll be looking at. And we want to be able to break that down by person, by month, maybe by the group. Are they a micro influencer versus like a, nano influencer or a mega influencer, or whatever it might be, number of followers they have. Or maybe we might want to compute that by time of day or day of the week or whatever it might be. We want some flexibility in being able to get this metric looking at kind of different angles of our data. The other one we want is conversion rate. So what proportion of click events, I see the post, I follow through to the website, actually lead to a conversion. So again, let's think maybe for some influencer, let's call him Michael. We have a whole bunch of posts, and looking at all of those posts, 100 people clicked through to the website. We have 100 clicks, but out of those 100 people, only 3 of them make a purchase. Then our conversion rate is 3%, 3 out of 100. Those are the 2 things that we want to be able to compute. And we don't want to just create those numbers and just put them in a file. we want some flexibility to, again, group them different ways as we see appropriate. And maybe, downstream as our manager or our collaborators might see appropriate. Okay. So that is the task for today. We're dealing with this Excel file. It has these two different sheets. We're going to need to match them up, and we want to be able to compute some metrics. Now, why do we need to match them up? Well, of course, we had a conversions table. That gave us the number of conversions per person per day. And we had a posts table, which we could use to get something like the number of clicks per person per day or something like that. So we need to get those into sort of one data structure so that we can actually compare them. If we reference back to Excel really quickly, I think we can kind of see, like, if I wanted to know the conversion rate for, let's say, Rachel Kelly on January 10th, 2019, what we're looking at right here. Well, I would need the number of clicks, and I would need to match that to the number of conversions. So I'd have 42 clicks, and Kelly, looking at, what do we say, January 5th, 1 conversion. I would need to get those numbers next to each other, right? So that I could do 1 divided by 42. And so we need to, do a little bit of work to get those tables lined up. And here's where we're going to start jumping in and using, some Python and some pandas. So pandas is a library that we'll use all the time in the data science fellowship, as well as the data analyst fellowship. It is the kind of the gold standard for working with tabular data tables, right? In Python. It is intuitive. It's very performant. It interfaces with a lot of different kind of inputs and outputs, and it's very actively maintained, and it has a really deep community behind it. So we're using pandas, and we're going to be reading in from that Excel file. Make sure we're running our cells as we go along. This is just going to be seeing if we have a directory where we're going to be, putting our final results, our reports we're creating later. But here what we're going to do is I'm saying pandas.read Excel. So I'm reading in an Excel file. It says report path. Basically, it's this right here, plus my data directory. And I'm saying I want you to read that with this particular engine, OpenPyXL, which I note above we need because of the version of Excel that this was made in. And I'm saying I want I want sheet 1, and I want column 0 to be the index column. And that gives me this. And really quickly, I'm just going to take this date right here, and I actually want to make sure that is not just being thought of as a string of characters, but rather as a date time object. I'll talk about that more later, but that's what I'm doing right here. I'm saying take the date column of posts, turn it into a date time object with those same values. Let's load in our other table. So I'm saying conversions, again, read Excel, all the same stuff, but here I'm saying sheet name equals 0. So that's my first sheet in the file, and then posts was my second sheet, 0 and 1. And conversions looks like this. Well, okay, we've got all these values that say NaN. What's really going on there? Well, those are basically blank values. It means not a number in pandas. It's basically null, it's empty. For us, we know that that means there were 0 conversions that day. So we're going to just fill those with zeros, and it's going to end up looking kind of like this. And here what I'm doing, where I'm saying dot head, that's to say give me the first 2 rows. I make this dot head 10. Then we can see a couple more rows, and so we can convince ourselves that it's the table we saw in the Excel file. All right, we have stuff loaded in. Pandas is now showing us this output. It's not really clear what it's doing for us yet, but we now are going to do a little bit of work to merge these things together. By the way, on some of the larger blocks of code here, I'll probably be going kind of fast. The intent for today is not to get everybody totally ready to go with pandas and working with Excel and so forth. so much as to demo some of the types of things that you will learn to do in the program in the context of like a real world business problem. So just keep that in mind, and please bear with me if we're a little bit quick on some things. Okay. Again, we need to merge our tables together because I would need something like conversions divided by cost for my cost per acquisition, or conversions divided by clicks for my conversion rate. That information's on two different tables. So I'm going to want to create a new table that kind of looks like posts, but has a conversions column. If I had something like this, and there was just another column over on the right-hand side, and it said conversions, well, then it'd be really easy for me to do something like, just take conversions and divide it by clicks, right? Just divide this new column by this column, or maybe, group by my influencers and add up everything and then do that. So my goal is to tack on a conversions column, as appropriate. And how am I going to do that? Well, I need to start transforming the tables kind of from the get-go to get them ready for this. And the first thing we're going to do is change the shape of our conversions table. So if you recall, conversions is in this funny format like this, where the dates are going horizontally. So they're different columns. And we want to match something where the dates are different rows. So there's one column that says date, and then we have all these different rows. And so to go from this kind of wide format to a long format, we're going to use a function called melt. And so what I'm saying here is conversions.melt. So that is this melt method. So I have my conversions object, and when I say .melt, it means it's a function that is acting on, this object. It's a function that is bound to this object. And I'm going to say, well, and we'll kind of see what this looks like actually. So I'm saying conversions.melt. I'm giving a few arguments to this function. So I'm passing in sort of some options, right? I'm saying ID variables, influencer, variable name, date, value name, conversions. And again, we'll see what that means when I run this cell. So it gives us a table that looks like this. I said my ID variable is influencer, which means that column stayed the same way it already was. Nothing changed there. I said my variable name was date. That means that all of these other things get squished into a new column called date. And my value name is conversions. So all the stuff that was inside the table is in a new column called conversions. If I had not passed in any of these things, and I just said conversions.melt, we would get something like this. This is the variable and the value, the variable and the value. But we said to keep this one the way it already was. And that way all the other columns become variable here, and all of these cells become this value column. But then I said, let's call this date, let's call this conversions. So that's the first step. We're melting our data frame down. And now I want to take these dates and I want to make them date time objects. Again, haven't really gotten to why that's so helpful for us quite yet, but we're headed there. So I've made that date time, and now I'm going to merge these two things together. Looking at posts once again, here we have influencer and date and conversions. That can match up with influencer and date. So what we want to do basically is I want to say, for instance, here I have Brandon Gonzalez, January 1st, 2019, 0. Well, I want to go through this table and find a place where the date is January 1st, 2019. The influencer is Brandon Gonzalez. And I would want to put a new value over there, 0 conversions. And that's what's going to happen when I say posts, which is this one, .merge with melted. And I'm doing so on these two columns that I'm specifying. I'm saying let's match on date and influencer, date and influencer. And notice that, I can give separate names for each one, the left one being posts, the right one being melted, which is good because I actually accidentally made this lowercase. But even if it was named something like spaghetti, we could still say, spaghetti there, and it would match appropriately. But it's called influencer. And so we are merging those things together. Oh. It looks like maybe my kernel might have frozen there for a second. Interesting. It looks like my notebook froze for a second there. Now it's working. I'm not really sure why that happened. So again, we merged those two things together, and now we have what we wanted. We have all of the stuff from posts, and we've matched that up with stuff from conversions. I wanted to double check back in Excel, for instance, that Rachel Kelly on July 28th, or I'm sorry, January 28th, one of the other J months, has 0 conversions, just as an example. Of course, we're not going to go through all of those, but 128, 0 conversions. So everything's lined up. OK, so we wrote some code that did all that fun stuff. Now we want to take this and wrap it up into a function. So that way, I can have just one reproducible bit of code, which I'm going to call load and preprocess. I'm going to pass in a path leading to that Excel file, and it's going to do everything that we wrote in the cells above, and a little bit more. And that way, anytime I want to load and preprocess my data, I can just say load and preprocess, and then pass in a path. And that's what we see here. By the way, I defined this report path thing earlier in the notebook. It is just a string that tells us where the Excel file is. So now we have this, kind of packaged up bit of code, this function we can call with a particular input and get the appropriate output. That's going to be really helpful for us in the future if we want to do this process with, new files. And it's going to help us keep our code, modular and easier to figure out where things are breaking if they're breaking. A lot of good stuff happens when we use functions appropriately. All right, so let's get into the actual analytics now. Now that I have the data that I needed, I can look at computing something like cost per acquisition, and as well as conversion rate. So I'm writing functions for these here. These are going to take in a data frame like the table I had above. They're going to check to see if conversions are greater than 0, because we can't divide by 0. So this will just double check that. Probably could have done a little bit more to really rigorously define this function. But if conversions are greater than 0, I'm going to take cost. I'm adding up all my cost, and I'm dividing it by all my conversions. How do we use this function? Well, I'm actually going to use it in a sort of group by way. So if I say, give me my data frame, group by influencer, and then get that cost per acquisition. Oops, sorry about that. Then it's going to take all my influencers, and over all of their posts, it'll add up the cost. Over all of their posts, it'll add up the conversions, and it does cost divided by conversions. So here's my cost per acquisition. This tells me that, with Albert Taylor, for instance, I spend on average $29.09 to get a conversion. Contrasted with, let's say, Lori Young, for whom I'm spending nearly $1,200 to get someone to buy something. We can imagine why this is probably useful. Some of these influencers are probably giving us a little bit more bang for our buck than others, right? But we might want to look at that by influencer or maybe by month. And if I did month, well, I can just say, all right, let's group differently here. Let's group by month. Let's look at cost per acquisition. OK, What if I wanted to look at influencers and over time, right? So influencer and month. Well, that's something I could still do. What if I wanted to look at something like the follower group? Spelled like that in my thing. Well, I could certainly do that as well. And so the way that we're writing this, sort of modularized and using these functions in a sort of appropriate way, makes it really easy for us to compute the same metric across different, different levels of aggregation. Just for completeness, I guess I could do follower group and month. Oops, month like that, and so forth. Let's do something similar for conversion rate. Here, basically, I'm dividing conversions by clicks, where above it was costs divided by conversions. But we could do the same thing. So I could take this and, I could just substitute in right here where I had my cost per acquisition function. I could say conversion rate. And so now I'm grouping by these two things and I'm getting my conversion rate. I could even pass in a little list of these things. Oops, actually, I'm doing that kind of incorrectly. And so let's actually skip on that because that was not the thing I meant to show. But in any case, now we're able to compute our metrics. So we have conversion rate and cost per acquisition. We've written those in a manner that we can do this different aggregation very simply. So just data frame, and let's recall that that's our table. Data frame dot group by, and if I wanted to see my metric for each follower group, group by follower group, each month, group by month. If I wanted to go by both of these things, I put a little list, right? List follower group, comma month. And then I apply one of my metrics and I get something like this. Great. Now, how do we get this out of the notebook? And also, how do we make this more, kind of reproducible? Or how do we make this, I guess, as automated as possible, right? And maybe we even want to start working towards a point-and-click web app where maybe someone could upload an Excel file and they could explore the data and compute this with different groupings. Well, why don't we take everything we just did and wrap that up in another function? So I'm going to write a function called generate report. And this is going to basically compute a number of metrics for some grouping column or columns. And now just to demonstrate that, we can, everything we've done up to this point, so loading in the data, I can do that now in basically one line of code because I wrote that function, and generate a report in one line of code because I wrote this function. And so if I group by influencer, then generate report is going to give me a data frame that looks like this. So I'm looking at conversion rate and cost per acquisition, but I've also gotten my total values for number of posts, cost, clicks, and conversions, just sort of the raw data that we had. I can do that by influencer. Again, I can do that by influencer and, influencer and month. And that's kind of what we're dealing with here. Now, based on something like this, I could use this quickly to figure out, let's say, like the 5 influencers with the highest cost per acquisition. And if we have a high cost per acquisition, it means we're spending a lot of money to get someone to buy something. So here are some people who we might want to, re-examine our current marketing strategy. We've made 25 posts with Lori Young, and we are spending this much money. We've only gotten 3 conversions. Yeah, so that's, a couple of different things we could do. I could also say, like, what about those who have the lowest cost per acquisition? Now we're seeing, okay, well, here are some people for whom we're only spending like, $30 or $40 to get someone to buy something. Maybe we should allocate a little bit more budget that way, right? Let's wrap this up then in thinking about how do I take these results, which certainly seem useful. How do I get them back into a format, that my manager or my other collaborators who are not, used to working with these tools, where they can see it, they can maybe work with it further, they can present it to someone else. And we started in Excel, so why don't we write things back to Excel? And what I'm going to do now is I'm writing another function, and I'm going to take in my data Excel sheet, and I'm going to export another sheet that actually has like the original data in there as well. And I don't want to go through all of that code because I want to make sure I leave some time for Sierra to wrap things up. But I'll point out some of the main parts here. So I'm loading in my data. I am generating a report like the one that we saw above. I'm doing that by influencer, by month, one of them where it's broken out by influencer and month. And I'm going to take all of those and I'm going to write them into an Excel sheet. To do that, I'm creating this Excel writer object, has a certain output path, and I'm defining that actually as a parameter of the function. And so using this writer, I'm going to say, cool, well, let's take one of my data frames and let's say to Excel. And I'm going to give this writer, and I'm going to name a sheet. So my monthly report to Excel, to this Excel writer, call that report month. The one where I split it by influencer and month to Excel, to this writer, name it report influencer and month. And then I'm going to say writer.save. That's going to close out that Excel writer, save the Excel file, and we can see it and download it. So I write this function. And OK, we don't see a whole lot happen. But if sorry for the scrolling like mad there, clicking back on Jupyter up here, that'll take us back to the root of our tree. And if we go back into demo 1 and into reports, we just created this file here, influencer report 2019 Q1. And I'll just demonstrate I have that pulled up on Excel because we can't natively open and view an Excel sheet in Jupyter. But we've created something like this. I have these 3 sheets here, influencer report, monthly report, influencer and monthly report. And that's kind of what we have created. And the really nice thing, in the way that we've built this so far, what's really nice is that I could actually take a different file and, maybe it's like the following quarter. And that's exactly what we'll do really quickly. So if I look here in my data thing, we had our first file, which was this one. I have another file, so it's Q2 instead of Q1. And I'll just point out that at the top, we had created this variable called report path, and that pointed to my Q1 Excel file, right? So I'm just going to say, OK, well, what if I was going instead from with the Q2 file, right? And then here I should make this say Q2 as well. So my data from Q2 becomes my report for Q2. And this function will run just the same. And I guess if we look in here now, then just seconds ago, we produced this Q2 report. We are free to download these things from Jupyter, again, just because of the way that Excel works. We can't actually view them like interactively in this server, which is why I've been switching windows. But that is kind of the long and short of it. We've read things in from an Excel worksheet with multiple sheets. We've combined those tables. We've written some functions to compute metrics, and we can group those tables in different ways depending on what's useful for us. And then we've written a function to do all of that stuff and spit out a new Excel sheet. We showed how that can be used to generate the same type of report for different Excel files from different months or quarters. in part 2 of this demo, which I will be giving, I don't remember the exact date, but it's upcoming. We'll see how we can take this stuff and actually start packaging it into something that could be interactive, where maybe, I can start putting a tool together such that my manager or collaborators could go to a little web app and upload the file and explore the data and compute those metrics interactively. And what's nice is that because we've written all this, in these clean functions, basically we can copy and paste them into a new script where we would start making that app. Again, that's all for another day, but we have set the groundwork for that in this sort of like rapid prototyping phase in the notebook. All right, that's going to wrap things up for me. We'll be able to take questions at the end of Sierra's presentation. So any questions you have about this, please hold off on those and then put them in the Q&A, and we'll get to those in a little bit.
Thank you, Michael. I will share my screen again. Okay, just a little bit more information about our program. A big component of our program that we really pride ourselves in is helping our students not only grasp data science or data analytics concepts, but also get a job in that field. So our analyst program is brand new. We don't have data here just yet, but for our data science fellowship program, we see that 97% of our students that go through our program are currently employed outside of academia, and 82% are employed within 6 months of completing the program. Those are really great numbers. We're very proud of them, and we work really hard with our students to get those. And that's really part of the challenge, not only learning the content, but being able to transition into a data science role. And that's really where our program stands out, because we help you to do both. So where are our graduates now? Where are they working? What are they doing? Again, data is not available just yet for our analyst program, but for our data science fellowship, this will give you an idea. Our graduates are working in 55 different industries. Some of the most common industries we see are computer software, internet, IT, financial services, and biotech. And some of the typical job titles we see are data scientist, data analyst, research scientist, software developer, and product manager. These titles and roles vary depending on the company and industry, but these are just some of the roles that we've placed in the past. And here is a short list of some of our data science fellowship hiring partners. Many of these companies are also hiring for data analyst roles as well, but we are focused on building a separate network of hiring partners dedicated solely to our data analyst program. We get questions about financial options and if we offer assistance, and the answer is yes, we do. In addition to our scholarships that we offered, we have partnered with LEAF to provide an income sharing agreement. It's a great opportunity for students who come participate in the program with just the deposit down, and you won't be required to make any payment until you've graduated and are working and earning more than $40,000 annually. We also provide loans through Ascent, and Ascent offers 3 options. One is a deferred repayment, so no payments during the program and for 3 months after. 2 is an interest-only repayment, small interest-only payments during our program and for 3 months after, and then full payments. And then 3 immediate repayment options, and that begins making payments 1 month after the program begins, and there are 36 or 60-month terms available. And lastly, for many of our part-time programs, companies are willing to sponsor or pay for their employees to go through a program. It's a win-win. You get to learn great stuff in the evening and be able to apply it to your job during the day. If it's something that you think your company would be interested in or you would like to present to them, we do have a letter we can provide you with to help lay out the program and all of the benefits of attending. So where are we at right now? Well, we run cohorts multiple times a year, and our summer cohort will actually be starting class at the end of this month, but the application for our fall cohort is now open. Our fall cohorts will run from September 20th through November 12th for our full-time programs, and September 20th through February 4th, 2022 for our part-time programs. Again, as I mentioned earlier, the full-time cohorts are 8 weeks long and the part-time cohorts are 20 weeks long. And then some specifics about our data science application. We ask that you submit your application by July 9th for our early admissions. You'll then have 72 hours to complete the coding challenge from the time that you open it, and the challenge deadline for early admissions is July 12th. You can't complete the challenge unless you submit the application. So just in general, I recommend you complete the application and challenge sooner than later to avoid any technical issues. We're unable to reopen the application or the challenge after those deadlines. And that's for our early admissions. We also do a regular admissions after our early admissions cycle. And what's the difference there? Well, we really evaluate applicants on a first come, first served basis. So if you want to have a better chance of getting a fellow spot or just knowing earlier if you've been accepted into the program to secure financing, I absolutely recommend applying for our early admissions application. We also offer a priority enrollment package for our data science program that includes access to a Python training course, early access to career services, and a one-on-one with a data science resume writer, as well as $2,000 off your tuition for direct payment. Some specifics about our data analyst application. Our application, again, are broken down into 2 parts before we make a decision: the application plus that optional diversity scholarship you can apply for, and the interview. The application deadline for the data analytics program is July 30th, and decisions will be made mid-August. And if you're interested in applying to our programs, which I hope you are, you can go to the dataincubator.com/apply to submit your application. We'll also link that in the chat. And if you have any questions about your specific situation, this presentation, or going through our application process, please, again, reach out to admissions@thedataincubator.com, and we'd be happy to answer your questions. So at this point now, I will open up the Q&A. If you haven't put questions in there yet, now is the time to do so, and we will answer those live. So the first question I see in here, looks like a 2-part question. Maybe I can answer that second part, but Michael, if you can help me out here. It says, by familiarizing with the materials Michael shared, would that be enough to be successful in the program?
Sure. So I would say that the topics covered, like the depths of the topics covered in this demo, are really just scratching the surface of what we would do in the data science or analyst program, as far as, and using pandas and pandas is just one aspect of both of those programs, and there's a lot more that goes on. That being said, pandas is a really fundamental skill, and so if you use this as a guide and you get familiar with what's going on in here, you will be set up for success. But I wouldn't say that it's, you would be necessarily good to go for everything. You would give yourself a good foundation though if you familiarize yourself more with pandas.
And then the second part there, would it be possible to switch from full-time to part-time or vice versa in the middle of the program? So no, we do not allow students to switch in the middle of the program. You'll need to finalize your decision before class starts. So you'll have up through that first week to decide which program you'd like to stay in. But after that point, then you'll have to remain in one or the other. Any other questions? If you have a question that you'd like answered live, please put it in the Q&A section. Or if you have more specific questions that are tailored to just your situation, again, please email us at admissions@thedataincubator.com. Again, if you have questions, please put in the Q&A section so we can answer those for you. Okay, I'm not seeing any other questions in the Q&A section. Again, if you have specific questions, please email us at admissions@thedataincubator.com, and we'll be more than happy to help you there. And then also you can visit thedataincubator.com/apply to submit your application. Thank you everyone for attending today, and we look forward to seeing your applications or answering your questions soon. Have a great day, everyone.
Thanks, everybody.